So next up is Richard Hughes. He's going to talk about a fundamental part of the firmware ecosystem, I believe. Because whenever you update your firmware, whenever firmware updating is occurring, or you need any metadata about information, you're probably using the LVFS. So yeah, Chris is going to talk about that. So give it up.
Thank you. Can you all hear me? Brilliant. So my name is Richard Hughes. I work for Red Hat. I'm a principal engineer. I've been working on Linux stuff for about, I guess, 15 years, 12 of them at Red Hat. So I've been doing this stuff a long time. I maintain all the stuff you see in these slides, and also some stuff, like other stuff like UPower, NUM software, and other stuff that you might be using on your desktop right now. We always hear a lot of bad news about firmware security, and the LVFS is kind of a way of making it a bit better, making it easy for the ODMs and the OEMs to do the right thing without having to reinvent everything. So there's really 4 parts to this problem. The first tricky part is users don't actually know what hardware they have on their system. Users don't know whether they have a SATA drive or an NVMe drive. And they don't know what hardware is updatable. And even if they did know what hardware was updatable, they don't know what firmware versions they're running. Some tools it will tell you in the journal, some tools it will tell you if it's running some random proprietary tool. But they also don't appreciate how important some updates are. Like, to update your mouse firmware, if your mouse is working fine, seems ridiculous. But then the Logitech mouse jack vulnerability came out, and actually it became critically important to update your unifying receiver. And even if the user does know what hardware they have installed, and they know which hardware they need to update, they don't know where to get the updates from. Like, personally, I don't go to support.dell.com and search for my hardware once every 6 months. And it doesn't help that although the hardware might say Dell on the outside, it might not be Dell on the inside. It might be a Intel chip or a VIA hub or something. And even if you do manage to get the update, actually applying it's really hard. So you can, like in the old-fashioned days, you'd have like a boot disk with autoexec.bat, and you'd have a keyboard and a mouse, and it'd be disastrous. Or maybe you require a Windows 8 system to update the system. So actually, even if so the users have no chance of getting this stuff right. So about 6 or 7 years ago, I invented this thing called a color hug. Color hug is like a display colorimeter, which measures the display, the colors portrayed on the screen. Now, as part of that, we shipped the hardware and had user updatable firmware. So I made a GTK application for flashing the hardware. But it felt really wrong that all the vendors had to re-implement all the same UIs, all the same system tools and stuff, just to be able to update something as easy as a USB disk. It just seemed wrong that there wasn't some common way of doing it. And about the same time, my boss said to me, he goes, yeah, we've had some requests from various customers that we'd like to get BIOS updates working. Now, that's really hard. So UEFI BIOS now isn't this old-fashioned system which only updates will be released to add new hardware. This is a system that if you don't update it has potentially remotely exploitable security problems. And so rather than vendors doing an update, say once, just to add support for a new CPU, actually it's critically important for things like compliance reasons. If you're PCI compliant, rather than just having the OS updated, it now be a requirement that you have to have the firmware updated. And so we had none of this functionality in place. Now, I kind of think my boss wanted me to just make the Windows executables work, but that's not kind of where we went. So what's the easiest way to infect hardware right now? Is it missing protections like missing boot guard or BIOS guard? Is it a failed root of trust implementation? Is it implanted updates like from the NSA, or you actually, or a supply chain attack? Is it using an unsigned updater like ASUS did, so you could flash anything using the ASUS updater? Or is it malicious devices like a DMA attack? But the light blue one is actually the far easiest. 99% of people will never update their firmware. And so you go to the vendor website and you find any of the CVEs as affected by that vendor, and 99% of the time, that's the easiest way to infect the hardware. That's the bit I want to concentrate on. So how do we fix this? This is split up into 2 sections. FWUpd is a 100% free software daemon. It's super important that it's free software, and I'll come to explain why later. And it provides the mechanism. It provides here is a blob of data, here's a file, put that file on this SPI flash, or put that file on the unifying receiver. And it's used by millions of users, but typically not directly, typically using a GUI rather than a command line. Now, having a mechanism is great, which means we can have this standardized dbus way of updating hardware. But without actually the metadata from vendors, what updates are available, what's the description for the update, it's actually not that useful. So the LVFS website is another project, which is, again, free software, and provides the data source. So the idea being that the vendor, like Dell, HP, Lenovo, would log on, upload for instance, a capsule or any other DFU update file, along with high-quality metadata. And that is then used by end users to flash onto hardware. So this is kind of how it works as a diagram. The top level is the internet side. So the LVFS provides a shared metadata on a CDN. The architecture is based, so it's a client-side matching. So it's not like Windows Update where you upload all the details about your hardware to Microsoft and they send you the results back. Everyone downloads the same metadata catalog from the LVFS, which means we can use a dumb CDN, which makes it really cheap. And also means we don't have to deal with the privacy implications of that. This is then downloaded by the session software, which isn't running as root. It's not safe to download stuff as root. And so both the metadata and firmware is downloaded by the session client and then squirted into the daemon that's running as root using a file descriptor. FWD then talks to the entire system. It's using systemd to schedule offline updates. It's got a pending database for offline updates and also to record updates that it's done already. It also has this concept of plugins. There's about 15 plugins, I think, now, another maybe half dozen in development, which are responsible for updating specific protocols. So you have a plugin for NVMe, have a plugin for DFU, a plugin for a proprietary, like a Realtek updating protocol. And as long as the plugins are free software, it doesn't matter that the protocol is proprietary, as long as we have the LGPL source code. So this architecture allows us to have this really high-level UI on top. Now, from all the research we did all those years ago, if we make this complicated, no one will ever do it. So there's two things we took away from the research. One, that it had to be easy. So it had to be in the software center and literally one click to be able to update the hardware. And the other thing we found from users is if we ever get it wrong, we will never regain the user's trust. This stuff has to be bulletproof. If the user bricks their hardware, they're never going to use their system again. If we get them into a state that's recoverable using a command line, but they have to then they can't use their computer for school or college or whatever, they're never going to use our system again. And they're going to tell everyone on Reddit, Twitter, whatever, how much of a stupid idea this is. So this stuff has to be bulletproof. It also has to be really easy to use. Some devices, we don't have the luxury of being able to reboot them automatically into some bootloader mode. So some devices, we actually have to do stuff. We have to hold down a menu button while we turn them on, etc. And so one of the requirements for the LVFS is that if we do have this manual step, it needs to be in this line art style, clearly explaining what the user has to do, so it's not sort of scary. The other thing is it needs to be translatable. All the metadata coming from the LVFS is translated. If you don't speak English, hold down left, right, start for 3 seconds is utterly meaningless. And so you've excluded a good sort of 2/3 of the population you want to get firmware updates. So it all sounds awesome and it all looks very good. It does sound scary, the fact that we can send millions of firmwares to end user systems without any checks and balances. So we kind of have this layers of security model. We have the firmware itself, which is this bit here. And this is then signed with a GPG or PKCS7 signature on the LVFS. This is the detached signature, deliberately detached, because we don't want to change the original capsule file or DFU file in any way. We don't want to change timestamps or invalidate existing signatures. This is included in a cabinet archive, which seems an odd choice, but it means that the vendor like Dell, HP can use the same deliverable for Windows Update as they do the LVFS. So for a small interoperability pain, we can actually make it a lot easier for the vendors. It also We support INF and CAT files, but we don't actually do anything with them on the LVFS, which means you can either upload the file to Windows Update and then the LVFS to get it signed in both places, or vice versa. And we added a README file for explaining what the extra files are. This cabinet archive is served over SSL from FWD directly, doesn't go onto the CDN. There's only a download every few seconds. It isn't a big load. But this is referenced inside an AppStream XML document. This is the file that tens of millions of people download to see if their hardware has updates on the LVFS. This is on the CDN. This is then signed with a GPG or PKS7 signature. I say or. Some companies can't use GPG for not very good reasons. Some companies can't use PKS7 for other equally bad reasons. So we support both. So the LVFS is really just a website. It's a website that can run cron jobs. You can kind of big it up as this great big thing that's really useful, but actually it's really just a Flask Python website. So if you're a vendor like an OEM or ODM or even IBV, you can upload firmware files to the LVFS and find out how many downloads you have over a certain number of days and find out telemetry about those downloads. And what's really interesting is we can have this bidirectional feedback model. Traditionally, when you have a firmware update on an FTP site or something, you don't get any information back from the user about the update itself. So in this model, we have an optional report from end users which say, this firmware was applied successfully, top one. Bottom one, it failed, the unifying failed. Which is super useful. This is only for people using FWD on the command line, on the assumption that if you're using the command line tools to update this stuff, you're probably in a position where you understand the ramifications of uploading things like your kernel version and that kind of thing. It's not something we do for people using the GUI tools. And doing this also lets us do some really cool stuff which basically lets me sleep at night. So that if there is a bad update that goes out from an OEM, if many failed reports come back, then we automatically pull that firmware back from the stable repository to an embargo repository. Yep. So the other thing it allows us to do with these these reports is we can sign them. So that seems like most of the data from the internet is random people we don't know, and so you can't trust the data other than maybe from a stats of 1,000 people, it worked successfully for, and one person it didn't, then maybe you can use that as a metric. But if you sign the report with a key, with a public key that you've attached to your user account on the LVFS, someone like a QA engineer in Dell could upload a report on the command line, which we would then use for trust. So for something like checking the PCR zeros, you can see here that we've had I think it's 1,000 downloads, 34 people have uploaded one PCR zero, but one person has uploaded a slightly different PCR zero, which is, from an attestation point of view, a bit weird. Now, if Dell uploaded a signed report, we'd get an actual value which we could compare against and then warn this person. But so far, not many vendors have done that. Work in progress. So with the LVFS, there's obviously massive privacy concerns. So vendors have to trust me that I'm not going to change their firmware. They have to be sure that if they're uploading embargoed firmware, then I'm not going to leak that embargo, especially if it's a CD or something. Now, there's lots of solutions there. One is you can mirror the LVFS. The LVFS for all public firmware, has a pulp URL, which lets you basically mirror it to a hard disk or to an NFS share somewhere. So if you're someone like Google who want to update 10,000 computers, you wouldn't want 10,000 computers all connecting to the internet and downloading the firmware themselves. You'd have just an NFS share somewhere. The other way you could do it is you can also set up your own LVFS server as an intranet thing. So you then re-sign the firmware with your own PKS7 or GPG keys, and then manage the flow of updates like that. And then there's also another thing that I might show you later, which is an enterprise dashboard, which also lets you kind of throttle some of the updates in your organization. The other thing is vendors are really, really secret. I used to work for a UK defense company, and hardware vendors are an order of magnitude more paranoid than a defense company. So a lot of the secrets that they think are secrets really aren't. So a good example would be a proprietary update protocol. So if you're using something like NVMe or ATA, FWD supports you don't have to write any code. You literally just upload the firmware to the LVFS and potentially push it to millions of users. But if you're using something that's essentially a vendor protocol which exists for no reason, vendors are often saying things like, can I ship you a Linux binary which you call, which will then update the hardware? The answer is no, because this stuff has to be audited by security teams. We have to be able to ship this stuff in RHEL and give it to banks and government contracts and stuff. This stuff needs to be completely auditable. So the answer I give them is no. So they come back and say, look, can we give you a static library which updates the firmware, which you call API into? The answer is still no, because it's not possible to audit it. And so it'll go back and forward. And what normally happens is the vendor says, well, it's a proprietary protocol which we can't tell anything about. And I say to them, well, look, let me guess your protocol. Is there a magic packet that sends the runtime hardware into bootloader mode? And then several more packets which, as a multiple of your block size, do an erase, a write, and a read, and then another packet which pushes the hardware back into runtime mode. And they're like, how did you know our secret protocol? Because all the protocols are the same. And so once you actually explain to the vendor that they have no IP and there is no magic secret here, and actually the fact that you could connect a USB analyzer and decode that in minutes means that they have nothing that's worth protecting. Some companies take a bit of convincing. So far, all of them have been convinced, with the exception of Broadcom, but let's not go there. What normally happens in that case, that some senior manager, legal team, etc., signs off a code release, and they send me 3,000 or 4,000 lines of really shitty C code, which updates their hardware. And we take that code, and with their permission to relicense it, we relicense it as an LGPL 2+ plugin, commit it upstream, and their 3,000 lines of C becomes 400 lines using all the shared helper functionality, because all the code's doing the same thing. They're all generating checksums, so we use a library function for that. They're all splitting the chunk of the blob of firmware up into 64K blocks. We'll use a function for that. And so actually we can strip out all of the stuff that they've sent us. And actually the most useful bit of the code dump is usually what error codes map to what, so like out of memory, wrong version, etc. With some exceptions, like some vendors have this like handshake that they need to do before the update's done, but most of the protocols are 99% the same. Yeah. So I guess some examples there. So Logitech said we cannot release you any code, but if you ask us a question, we'll tell you the answer. So over about 2 or 3 weeks, I'll ask them a question, and they had this shared Google Doc. And so they'd ask us a question, and I'd say, okay, well, is this field big endian or small endian? Small endian. And over about 2 or 3 weeks, we built this doc from nothing to a complete implementation, almost like a clean room spec of how to update their unifying hardware. Wacom, better, they sent me some suboptimal code, which we could then turn to a plugin. And even companies like Dell, they'll just literally send a pull request and say, look, this had support for our new doc, which is awesome. Now, obviously, this is a lot of trust in me. Now, with obviously, I control the LVFS, and so I can kind of see what the vendors are doing on the LVFS. But a lot of it's like an informal agreement in that if I ever, for instance, I don't know, released an embargoed hardware for Dell, Dell will stop using the LVFS. It would be the end of the LVFS. So it's kind of like a balancing act between making it easy to use and making it private. It's a really tricky balance, and there's lots of ideas there. So we also have this idea of vendor relationships. So on the LVFS, you have the ODMs, the IBVs, and the OEMs, and everything in between. And so we let someone like Dell or HP manage their own users. So Dell uses the Azure thing, so all their users are connected into their Azure system. And they don't have this, but other companies will manage the different user classes in the LVFS. You can see some users are, for instance, like analysts, where they can look at all the firmware and all the reports of failures and things. Other users might be managers that can add other users in their domain. What's really cool is that once we have all this software with this high quality metadata on the LVFS, we can start doing analysis on it. So using something like ChipSec, we can take the capsule itself, we can break it out, so we can decompress the PFH, we can unzlib it, we can break apart the FVH, we can then look at all of the EFI binaries in that image, and there's some things we can guess about them. There's not much information, there's not much metadata there, but we can see who signed them. We can see what the SHA values are. We can see if it kind of what GUID they're targeting, which means we can have this publicly available system to say, okay, well, who is using, for instance, the Intel Gigabit Ethernet controller? You can see that that same checksum there will turn up between different OEMs. So obviously the OEMs are just using the pre-built EFI blob, which is kind of interesting. We can also use it to keep the vendors honest. So once or twice we've caught the vendors out where they've issued a low priority enhancement only update. When you actually look at the shards that they've updated, the EFI binaries themselves or the ME partition, etc., actually they've done some security, they've sort of snuck the security changes in. So we can kind of keep them honest and sort of say, actually, I think you might have forgotten something in your release notes. Because we can compare all the updates in the LVFS with the previous one, which is super, super useful. Also, you can see here we've got the ticks. Now, I found it right from the start, the way to get firmware engineers to do anything is get their marketing department to call them. So if you have a red mark, a red cross next to a firmware, the marketing department rings up the firmware department and says, I don't know what it is, but you need to make that red mark go into a green tick. And that's a really good way of getting vendors to do stuff. Part of the deal with uploading to the LVFS is that we're allowed to do this kind of analysis, which means that we can do virus scanning and that kind of thing. So we can also do other checks, like for instance, we can check the EFI capsule. Is it actually a capsule header? If it is a capsule header, does it have the correct flags? Does it match the GUID that the vendors reference in the metadata? So we can do other checks like this as well. We can also check signatures. We can see who actually signed this EFI binary. And until we started off, and the allowance we gave them was that the signature couldn't be more than 3 years out of date, and half the firmware failed. So over the last few months, we've been gradually increasing the number of checks that we do on firmware, and also been making them more and more strict. So vendors are saying, actually, okay, well, sure, you can waive these failures. You can have a QA user from the vendor organization log in, waive the failure, then promote it to a stable. But actually, it's way less work if they just go back to Infineon or whatever and get it re-signed by the vendor, which is much better security. So we're kind of slowly but surely raising the bar for firmware security. Other interesting things. Now, this one's a really interesting one. It's just a simple block list. We basically take the DFU file, break it into elements. We take the ME update and we break it into partitions. We take the UFI binary, we scan the whole thing, and we also scan each UFI binary as well. I mean, any format that we can recognize on the LVFS, we can run it through this simple block list. So something like do not ship. You'd be amazed at the number of binaries we found to be defined by OEM in your DMI data. There was a vendor that was affected by that big time. And so we can kind of add more and more checks. Now, there's one that I've had to kind of gray out because it actually found quite a high priority CVE, which we can't talk about, which is fairly predictable if you understand what it's looking for. Incidentally, we're looking with this for UTF-8, UTF-8, 16, BE, and LE, which kind of finds all permutations of this data. So using this data, this historical data, it's kind of limited in that we only have a couple of years of this data going back. But you can actually see for this XPS model that updates were released every quarter, nearly all quarters. So if you're a purchasing department for a government or something, you can see that actually it's probably worth buying the XPS 13 over maybe a lesser known model because you're guaranteed support, because you have proof that the firmware is being updated. Now, of course, you could game this. You could just update the version number and then submit to the LVFS. But then we're going to find out because the shards aren't going to have changed. And so we can use this to keep the vendors honest as well. This is being used. This was actually a direct requirement for UK government, who wanted to be able to work out what laptops would be supported for X months. Now, in doing the LVFS, we have this whole model of affiliates. So, for instance, you can have an affiliate like Foxconn uploading to various different OEMs. And so the case might say Lenovo, but it might be made by various different ODMs instead. And you have this concept of an OBV, like an AMI or a Phoenix, etc., actually produced in the BIOS, which then the ODM will then take and build on and then ship to the OEM. But actually, it's really, really hard, much harder than that. Some in this chain, there might not be an OBV. It might be people are just cut out the OBV step at all. It might be that the OEM is responsible for all parts of the firmware update process, so including managing the QA and all the kind of the embargo stuff. So actually, there's a fairly complicated system to kind of map vendors on the LVFS, for instance, allowing one ODM to upload on behalf of Lenovo or another ODM to upload on behalf of Dell. And it does get complicated when there's various update protocols which are trade secrets, which are being used with the ODM that supplies Dell and the ODM that supplies Lenovo, etc. So it's sort of like lots of secrets, which is fine. Now, one thing I did get pinged, someone in Google was actually passing the command line saying, look, we want to find out what firmware versions are installed on the hardware on our systems. We're passing the command line that users use to find that out. And it's like, you don't want to do that. It's a terrible idea. So we created this thing called FWD agent, which basically spits out a JSON blob of what hardware you have that's updatable, and critically what firmware updates are available for it using the metadata that's on the device currently. And yeah, FWD agent is at the moment just an information provider, but we have patches which allow FWD agent to actually register with a remote web instance. So you can actually enroll the server, much like, I guess, RHND used to do. So you can actually see if your enterprise, what updates, what machines haven't been updated. That's kind of work in progress. It's maybe not something I want to do, but someone else might. FWD agent also has functionality so that you can, the remote web service can actually say install this firmware from this location, which makes it a bit more useful for things like using it in like Ansible and that kind of thing. So 3 years ago, when we started the LVFS, we were asking the OEMs and the ODMs, please help us. Please help Linux users, because we need to install firmware updates too, mostly on deaf ears. But in the last 3 years, it's really changed. We've now got people like Dell saying, if you want to supply hardware to Dell, if you want to be a supplier to Dell, your hardware needs to be updatable and on the LVFS. Google has increasing requirements for LVFS to be supported on the hardware. Red Hat, it's very difficult to get Red Hat hardware that isn't Apple, which doesn't have LVFS support. And interestingly, the UK and US have various governmental departments which refuse to buy hardware that isn't updatable. They don't want to be locked into these proprietary support contracts with various enterprise vendors, which basically means we changed in tone. So rather than it being me pleading with vendors saying, look at our Linux users, we have this number of people, et cetera, et cetera, et cetera. Now they're saying, if we don't get our firmware on the LVFS in the next quarter, we will lose this many millions of dollars worth of sales. What heaven and earth do we need to move to make this happen? And then I can say, well, you need to open this update protocol. You need to go back to your silicon supplier, and we need to talk to your silicon supplier about opening the protocol so we can get it supported in FWD, so we can get firmware on the LVFS, etc. This means I can be a bit more obnoxious when I'm asking for stuff, which is good. So we've come basically from nothing. We're now shipping, like the scale on the left-hand side is, like that top number is 900,000 firmware downloads a month. So, and you can't really read too much into it. This is kind of, I've had to fudge the numbers a little bit because Dell started off with a few models supported, but Dell basically co-maintained this entire stack So although Dell looks like a very small pig, actually a good chunk of these updates are probably all Dell, and they've rolled out for more models. Similarly, ThinkPad and Lenovo. Lenovo's a tricky one because they had to get all their ODMs and their silicon providers on board before they could do the big ta-da announcement. So actually, we had to work with Lenovo for months before we could actually announce ThinkPad support, for instance. And similar HP. So Christmas last year was just mad. So more and more companies were basically finding they couldn't sell stuff to the big OEMs. And so I was getting essentially an email every other week to say we need to get the stuff on the LVFS. I've kind of used the date that they uploaded their first firmware or was pushed to stable, but I've had to sort of fudge some for reasons. There's lots of logos you can't see there. Lots of companies test the LVFS in secret. They want to see if it's they want to see whether it's possible to support and what the whole architecture is before they commit to it. And because it's completely free software, it's completely free service. There's no cost at all. Engineers can try it out. Then engineers can go to their managers, and the managers can then go up to legal. Yeah, so there's lots of logos there that you can't see, but they are actually on the LVFS and will announce soon. Also, we have a search feature on the LVFS, so you can sort of go to ASUS and say, look, in the last month, 1,000 people searched for ASUS firmware updates, which they didn't find on the LVFS. Will you reconsider your decision? And that's a really powerful thing. So when we were kind of courting Lenovo, we could say, look, 20,000 people have searched for Lenovo, but have found nothing. So let's look to the future. I'm conscious I'm running out of time. I'd like to see an enterprise dashboard. I'm not sure I'm the person that wants to do it, but we need to be able to put all the tools in place, like the JSON output, etc., so that users can build something in Ansible or whatever, and produce something that's good. There are a few remaining vendors, like ASUS are interested but have done nothing. Microsoft say they're super excited and want to do it, but I then haven't done anything, and a few smaller vendors. And I'd also like to increase the number of tests we do on the firmware itself. So I have no problem with, for instance, the firmware files all get scanned with ClamAV, and they also get sent to VirusTotal, which does a more thorough virus analysis on the EFI binaries. And that's obviously a non-free service. And I've got no problem with firmware being tested for things like viruses or malicious code. You can even get like static analysis on them if you wanted. So I think that's where we look for the future. So thank you for listening to me ramble on. I can't answer any questions about what hardware is going to be announced on the LVFS in the future, nor which companies are hopefully going to release an announcement, etc. But yeah, thank you for listening.
Thank you, Richard.
So anyone got any questions?
We have about time for 7 questions.
7 questions.
Please, would you please go to the microphones to your questions?
Hi, great talk. Learned a lot. I was wondering about, few of the things that I come across is, you have a firmware that, what I notice is majority of this is being deployed for the laptop.
Yeah.
And how much of this is being integrated into enterprise? So you mentioned Google. But
so enterprise is hard. So laptop vendors and like desktop commercial stuff, they want to sell as many units as possible.
Yeah.
Enterprise vendors have looked at this, and there are 2 big enterprise vendors that are testing this right now, but they have this model where security updates cost money, and there's a subscription attached to that. They don't want to release that little cash cow. Now, I think that's absolutely crazy. Withholding security updates for money is insane. So I think the vendors will increasingly find it harder to sell what they need to sell, and will come to the conclusion that they're losing sales, but it will cost them less money and lost revenue compared to the loss of sales.
Okay, right. I have one more question before how do you do a canary? Like when you actually are ready to, you mentioned about throttling.
So that's a good question. So there's lots of easy things we can do and one massive failure in the whole system. So if you're doing like a DFU update, we check that the device came back with the expected version number, which is straight, because you can hit a runtime, there's no need for a reboot. If it's a UEFI update capsule, we wait for the user to reboot, and then on the next boot subsequent to that, we then check the version numbers, what we expect, and any PCR zeros are correct, etc. The major failure in this problem is if you actually sent a firmware update out, which bricked the computer completely, you have no way of getting that information back to the LVFS. Now, so far, that hasn't happened. But I don't think there's any way around that.
Thanks.
We have time for about 5 more questions.
5. I've only got 1. So I'm Simon Glass, the company in the top left. I worked on the Dell Latitude, and we used that your project. One thing I noticed, and we're looking at using it more, is that identifying the hardware is not obvious how to do that. For example, for touch screens, sometimes you can't probe it, that sort of thing. Is there a standard way to do that, or do you intend to standardize that?
So vendors reinvent that for essentially no reason. So for instance, like a Synaptics MST, you have a specific way to probe it using the aux channel, and it's very specific to the hardware. So I think realistically, it's a new plugin in FWFD for each vendor protocol. The plugin itself is responsible for updating the firmware, but also about enumerating what's there and like watching hot plug events and stuff. So I think the question you're asking is someone like, so for instance, like Synaptics are contributing an RMI4 plugin, which can then look at all the touchpads that exist for Synaptics. So, but then until their protocol exists, we don't know of the existence of the touchpad. Does that answer the question? You can ask a different question.
Sounds like it's a tough one.
It is a tough question because a lot of the silicons, you can't change silicon. And so you say to a vendor, well, if you use something like the new Microsoft CFU, to be able to enumerate across this cross-platform thing. But they're like, but the silicon we can't change. And there's 30 million units in the wild, which we have to support. So it's essentially more code, I'm afraid.
This Palsami, so is it a signing body for the firmwares?
Is it assigning what, sorry?
Is it a signing body like UFI.org? If I want to sign my firmware, so is it depends on the vendor to sign it, or do you have a general body to sign it?
So do you mean the signing from a UEFI point of view, or
or any other device firmware?
So at the moment, the LVFS has 2 signing ways. You sign the UEFI firmware from the vendor using the private vendor key. I don't have anything to do with that. You sign the binary itself. And then the LVFS signs it on top. And so if you manage to, say, hack the LVFS and you've got some random firmware that you self-signed, assigned by the LVFS, it would be deployed onto the user's computer, but it wouldn't be you couldn't update because it wouldn't match the user's hardware signing key. And so it wouldn't actually be deployed. Some firmware is totally unsigned, like Super AO firmware is unsigned. There's not even a checksum. And so it's easier you have to kind of rely more on the LVFS checksum and stuff. Does that answer the question at all?
Yeah. So it's pretty much where I was asking is how do you trust some payload coming in?
So a lot of it, like security, you can't solve security unless you get people involved. So sometimes it's literally picking up the phone and talking to someone and saying, okay, I need to talk to your legal department. And for instance, if you're HP and you want to ship stuff on the LVFS, I need to talk to their legal department to make sure that the person is able to upload the code and I can redistribute it without me getting in trouble. And so as part of that escalation, you get I guess it's social trust of doing that. There's no way of replacing that with numbers or computers. I think it's literally a person-to-person thing.
Thanks.
How do you think this looks with open source firmware? If you have the same kind of security methods, but since it's compiled separately, it's not going to match any of the checksums for other UEFI binaries from other IBVs. So the firmware, you could probably do a much more in-depth security check because you could identify the exact source code that it was compiled with, for example.
Good
Where
question.
do you think that goes?
So one thing I'd like to see, like I've been talking to one of the US government departments about doing a software bill of materials where you can find out like from an EFI binary what SSL it was compiled against, etc. So rather than just relying on its SHA-256 checksum, you can compare its software bill of materials, which is then signed by the vendor. That's a much better way of doing it. Just blind checksums is just because it's all we've got. But if you want to do this that'd be awesome. I should add that it's not just a proprietary software thing. Like I guess 20% of the firmware on the LVFS is free software, like GPL or other licensed. So I think something like Core Boot would make total sense.
Right. Please have another round of applause for Richard.
Thank you.
Thank you.